Hello everyone. Our topic is Poland detection based on Fusion Deep Learning Network. I'm the presenter, Zhou Sheng. I'm from Jiangsu Normal University, and this is my email. If you have any questions, please contact with me from this email. Notice the network of transmission lines is gradually spreading over the world. With the popularization of UAV and helicopter applications, so it's very important for low altitude safety aircraft to detect poor lines in advance. Uh, Why? Because hitting the poor line will cause serious damage to the helicopters, to the UAVs. So just see these two figures, we will have caused a huge economic losses and people's lives. So the aircraft obstacle avoidance mainly depends on the pilot's reaction and experience. So the aircraft in operation can avoid large obstacles, but small obstacles, small targets, such as problems, is hard to detect. The pollen detection is mainly used for aircraft obstacle avoidance of pollens, which can identify the presence or absence of pollens within the visible range in advance. So it's very useful for the viewers. The contribution of this paper is mainly have 2 points. One, a raw feather extraction module is used at first, which is combined with the inherent feathers of pollens. Second, a fusion output module with active weighting learning is proposed. So, one module, a residual module, and another inceptor module is combined together in this paper. The contents are listed as follows from the raw network architecture design, rough feather extraction, residual module, inception module, output fusion module, and the experiment results and analysis panel with got conclusion. But the overall network architecture. So the input image just give to the raw feather equation, and then to residual modules, and then to inception and full connection layers. Then got the output feathers for the raw feather extraction module. So it's the first step in the proposed pollen detection method. The raw feather extraction module is mainly composed of 3 multiply 3 convolutional layers, 1 multiply 1 convolutional layers, and bin layers. The main function of the bin layer is to speed up the training and convergence of the network. So the concatenation of the convolutional layer and the bin layer can be regarded as a convolutional layer. So the main channel of the module consists of 5 3 multiplied 3 convolutional layers. The left and the right branch 1 consists of 2 3 multiplied 3 convolutional layers respectively. And the left and the right branch 2 consists of 1 multiplied 1 convolutional layers. This is the raw feather extraction module. And the residual module. The residual module uh, can prevent overfitting while deepening the network. Uh, the main path of the residual module has three multiple three convolutional layers to extract feathers and two beans. Uh, the layers speed up the training and convergence of the network. As the identify mapping branch is composed of a one multiple one convolutional layer and a bin layer to adjust the input and output channels to the module. The inception module, for the inception module, uh, it can perform failure fusion of different receptive fields, and the failure is tracked by the residual module in the network. So the first branch expresses failures through the one multiple one convolutional layer and the bin layer. The second branch continuously passes through the combination of two 3 multiple 3 convolutional layer and the bin layer after adjusting the channel dimensions of the one multiple one convolutional layer and the bin layer. The third branch performs failure expressions through a combination of 3 multiple 3 convolutional layers and bin layers and adjust the channel dimensions of the 1 multiple 1 convolutional layer and bin layer. The fourth branch loops and sums image filters. So finally, the filters of the full branches are fuse and output. Fuse next, give the output fusion. Fuse four branches built together with different widths. These widths can adjust by themselves. So the experimental results and analysis, the data set, we can go to the data set from this this paper, and you can download from the website. This contains two subsets, infrared and visible light. Each subset contains two parts, include and exclude. It means pole length and non-pole length. Each part has 2,000 images. So total we have 4,000 images. The metric used is occurrency. Occurrency, where TP means give attribute keys positive, the prediction positive. T means attribute keys positive, prediction negative, and so on. First, we compare the proposed methods with the traditional image processing methods. We can find these methods from this paper. So also we are used the same public dataset. So we can compare with obviously our method is better than traditional based image processing methods. This one is experimental results and analysis compared with deep learning based methods. Deep learning. So the compared model just use the original model for the training data set. Also, our method got the best accuracy. We also do some robustness tests. We give the four sense, give fully use the digital image processing methods to make the image in foggy, in the strong light, snowfall, and motion blur senses to simulate the actual environments. So the actual environments, and also we got the accuracy in these four senses, and a generalization test. verify the applicability of the proposed method in the new environment. A new environment means a new data set. So we got the resource in table 1. So the main goal is we propose a deep learning based method for problem detection. So from the result, we can know that for the issue of not-so-profound performance robustness in smooth form and foggy environment, the fusion of infrared images and visible light images can be introduced in the future. For the issues and not so good performance robustness in motion blur environment, in the future we can use more stable and active disturbance rejection UAV trajectory tweaking methods to get better image capture effect. Based on the advantage of the classic models and the characteristics of the powerline images. So powerline detection method based on field fusion is proposed in this paper. And experience carried out with visible light streaming dataset. Diverse experimental results show that the proposed method is effective and have a good performance, robustness, and generalization. Thank you for your attention. If you have any questions, you can connect with me by this mail. Thank you very much.